Hi again, this is Betsy Scott with Ivicus. I'm the Director of the Best Practices Research Alliance. Thanks for joining us today for our webinar, Coping with Comfort Complaints, Issues, Causes, Prevention, and Troubleshooting. The subject for today's webinar came about really as we accepted some feedback from builders at webinars last year and events where you'd like us to talk a bit more moving forward about risk issues, risk management, etc. So we wanted to kick the ball off with that in talking about comfort complaints, and we've got two experts with us today that I'll introduce you to in more detail in a moment. Arlan Burdick with our Builder Solutions team, and Andrew Poerschke with our research group internally at Ivicus. And thanks for joining us, taking time today, guys. This webinar is being made possible through the Best Practices Research Alliance. I know some of the folks on the phone are members, others are not. We are a collaborative builder community first and foremost. We have 75 builder members currently, all of whom are interested in learning more about delivering home quality and performance, both from a business and a technical perspective. Our agenda and the resources that we offer are builder-driven, hence today's webinar. And our intent is really to create an open exchange of ideas and information with our members, as well as our sponsors. And I'd be remiss in not taking an opportunity to thank our sponsors today for making this session and all of the other great resources we're able to bring to you guys possible. For those of you who've been with us for a while, we have a couple of new sponsors, Dow Solar and Sherwin-Williams. So if you guys are on the phone today, welcome to your first webinar. There are 3 opportunities for you to participate in today's session. We have one poll, which will come up in the first few minutes of the session. So when you see a PowerPoint slide with that big vote sign on it, get ready to cast kind of your ballot and let us know what you're seeing in terms of comfort complaints on your end. You, at any point in time, can text in questions to us, and if it's appropriate where we are in the discussion, we'll address them on the spot. Otherwise, we have a couple of planned breaks throughout the session where you'll see this other slide with our hands raised high where we can facilitate answering those questions for you at that time. You can also click on the little raise hands button in your management set for GoToWebinar to raise your hand if you want to ask anything out loud, but we will need to call you by name so that you know that we've unmuted you. So just be aware of that. Forgive me if the graphics are slightly different than the current version of GoToWebinar. They've just changed it, but should be relatively similar. So look for those types of tools in order to connect with us today. As I mentioned, our speakers today are Arlan Burdick, who is a building performance specialist with Ivicus. He is a professionally trained engineer, but he is not practicing. But he has a really good, I think, combined background in having worked for a major home builder, so in the field, on the end, dealing with these issues, either as a customer care professional or as a construction professional within a major home building company. And he's also been with us for 8 years. He currently is boots on the ground looking at construction both proactively and reactively with our Builder Solutions team and our Perform offering. But he's also done some work on the research side, proactively looking at comfort and HVAC and can bring some of that experience to the table as well. Now, Andrew Poerschke is really focused on research for us at the moment. He has a background in energy engineering, and he's working on several Building America research projects that are comfort related, some of which have some real live data that he can plug in at key points in today's discussion to kind of validate some of the issues with some actual data from a research perspective. So we're not, this is not actually a research heavy presentation, but we do have a couple more sessions before the end of the year. We'll be sharing Building America research in more detail. And I'm sure Andrew will probably be part of those discussions as well. So I'm going to turn the floor over to Arn, who's going to act as our primary presenter today.
Thank you, Betsy. Good morning, good afternoon, depending on where you're at. It's myself and Andrew. Say good morning, Andrew.
Hey there, it's Andrew. Thanks for joining us, everyone.
Yeah, you can tell the difference between our voices. We're going to set the stage about how we're going to discuss the items here, what type of house we're talking about. We're going to go through some issues and proactive solutions for them, and we're going to go through some troubleshooting issues throughout the day. This is a really wide view of the issue. At the end, we will give you some resources that take a deeper dive into them, some published items that we have out there. So we will skim over the top and discuss in some detail, but not a super deep dive. First, we need to set the stage of what type of house we're talking about. We're talking about a well-built house, not necessarily a research lab house, passive house level, although some of these things do apply there. But we're really talking about a generally good house. Could be an Energy Star house, could be a zero energy ready home, could be a home built to 2009 or 2012 code that you've done a very good job on, where these issues can come up. Better windows, tighter construction, good air sealing practices, and insulation. Basically, the houses that we all are trying to build. We're really discussing the HVAC and mechanical systems here. We're assuming that, we're making an assumption, we're assuming that thermal enclosure is the better house, and where the comfort issues are driven by mechanical problems within the design or installation. There's four common complaint types that we're going to discuss. Very, I'd say impossible to discuss these as mutually exclusive items. They cross over each other. They can be two items caused by the same issue, or two issues causing, one issue causing the same item, same complaint. But stratification, high humidity in homes, hot and cold rooms, and then noise. Really, the distinction between stratification and hot and cold rooms is a tough one to make. The impact, what are the impact of these comfort complaints? The impact on the homeowner or the impact on the builder themselves? The physical impact on the homeowner, it can be a real health issue if the house is too hot, too cold, poor ventilation, high humidity, any of these myriads of things. We tend to hear more about too hot complaints. I think that comes from the fact that you can always go put more clothes on. You can only get so naked, and then you're as naked as you're going to get. Financial impact, if your homeowner is getting higher bills than they expected, you're going to hear about that, no doubt. The emotional impact is tremendous. If they're uncomfortable in the house, they may be complaining about being uncomfortable. They may also be going through the house and picking out every other little thing they can complain about to you and taking up your time simply because they're uncomfortable in the house. This all translates to the builder in money, both time and labor. No doubt your contractor is adding some portion to their price to you to cover complaints, to cover going back for warranty. There could be an inordinate amount being added to your cost because they are repeatedly going back for complaints. Possibly their fault, but they're still going to charge you for it. There's an impact to your brand reputation. If you get that irritated homeowner who's job-owning about how bad a house you built, that is a probably incalculable cost to you to try and recover that reputation. And then the dreaded litigation if things just get too far and you have to spend your time pursuing or addressing those issues. We need to understand what thermal comfort is so we can talk about it. This definition is from the ANSI ASHRAE Standard 55. Condition of mind, satisfaction, and subjective evaluation. No problem, right? We can deal with those things.
Clear as mud.
It's the human condition. You can have a hot person and a cold person in the same room, and you're trying to satisfy their subjective evaluation of that comfort.
Yeah, and so one of the things that we've done, this is part of a Building America project, is actually track the comfort conditions in a large number of homes in the southeast in a hot and humid climate. We put sensors in 37 plus homes and looked at a number of different aspects of the comfort within those homes. But one of the key measurements was the thermostat temperature. The thermostat is the main area where a homeowner is going to interact with their heating and cooling equipment. And what we see here from this data is a wide variety of different occupant schedules, occupant preferences when it comes to running their heating and cooling equipment. You can see that there's some people that looks like they have a regular setback, and some people, they just leave it flat and never touch their thermostat. The lines that you're looking at are representative of 5 days during the week of measurements taken at the thermostat and averaged for each hour of the day. So this gives you a quick snapshot to help understand occupant profiles. These profiles vary pretty wildly throughout the day, as you can see here.
Sorry about that.
Sam, I know we're not going to go into a lot of detail with this, guys, because comfort is a big issue, and you kind of have to draw the line on a 1-hour webinar with what you can touch on and what you don't have time to go into a massive amount of detail on. But before we get into more of HVAC-related causes, what might some of the enclosure-related things that you guys have seen in the field be that would track back to comfort?
We pay close attention to air sealing to make sure there's no air leaks drawing in outside air, unconditioned air into the house. We pay very close attention when we're out walking houses for builders to the quality of the insulation installation. You can purchase an R13 or an R19 fiberglass bat and install it in the wall in a manner that it's nowhere close to that rated R value. So we pay very close attention to that as well. Window quality, you're looking for primarily the solar heat gain coefficient, that blocking out that solar gain in the cooling season of the house.
Okay, great. Thanks.
So moving on to some of these issues and causes and prevention. Again, I'm going to say this maybe several times today, that it's very hard to separate these out into separate issues. But we're going to start with stratification. Stratification is a mixing problem, warm air rising, cold air settling. This can manifest itself as a hot or cold room issue. We're going to discuss that complaint in a different light a little bit later, but more predominantly and more troublesome, it can present itself as a hot second floor, cool first floor, with the impact in the heating and cooling system being differently. Imbalances in large volume spaces. We're very fond of 2-story large vaulted ceiling spaces, and they can be challenging to warm or cool given the volume of space in that room, and generally there's a lot of windows associated with those spaces. That's another place where this shows up. First cause for stratification, we're going to address this here in the stratification section, but it comes up in the hot room, cold room section as well. Register. Size matters, and so does location. The size of the register should align with the volume of air being delivered to that room. And the location of that register can have an impact on duct layout and how that air is introduced to the room. I'm going to let Andrew describe the photograph here. It's a project that he worked on here in the building.
Yeah, so what we did here in the lab at Ibicus is we studied the impact of varying the register size and more importantly, varying the airflow through that register and trying to understand the throw coming out of the register. So in this picture here, we just used regular room temperature air, so we weren't really looking at, say, buoyant effects of hot or cold air, but just standard room temperature air we injected some smoke into it and put a known volume of air through this register. And using photography, we're able to see where that air is going. And we really reinforced the fact that as you dial down your airflow, you have to be aware that it's going to impact the throw and mixing into the room. And if this is cool air trying to, say, cool the second story of a house, there might be an issue where you're not mixing that second story, and that cool air is, again, causing stratification. And so, register size is one thing, but also the register design is super important. Here we have a graphic showing the same size register. It's just a 4x10 register, but then the register is from several different manufacturers. And you can see that, kind of the spread is about 60% between, say, the bargain register versus the higher end register. So when you're thinking about the throw and the mixing that you're getting, it's more than just simply, thinking about the register size. You also have to understand the impact of registers, and that, cheap stamped steel register might not give you the same throw, mixing, and comfort that a slightly better designed register might.
So register selection is actually a fairly technical thing. It's more than just 4x10 or 2x8 or what type it is. The chart here is from an actual register manufacturer's technical data. I just want to point out the 5 items that go into selecting register. The face velocity, how fast that air is leaving the register. We're going to talk about noise later on, and that is really affected by the velocity. The pressure loss is a number that's included in the overall duct design. If it's ignored, it can cause problems. But really, the delivered CFM, how many CFM are intended to go to that room, and how far that air is going to reach when it slows down to the 50 feet per minute. That's not face velocity, that's terminal velocity. That's the place where the air reaches its point of least effectiveness. So it's the farthest out that air can reach. Some real life true considerations here. This may not be typical of your current residential designs. That presents challenges when you talk to your trades and ask for these things. It can be a barrier simply getting these at a reasonable cost. The trades need time to source this. Initially, there may be sticker shock. As they become more common in your houses that you're building, that price should logically come down. Betsy mentioned I did work in purchasing. First cost is a real consideration in all the things that we talk about. Another cause of stratification can be poor return design. The image, the photograph, is a return in a kitchen island, blocked predominantly by the stools and people sitting in the stools. You want, in your return design, a good low resistance path of air to get back to that equipment. Other considerations with this location of the grill is being that close to the cooking surface, bringing kitchen smells and redistributing them out throughout the house. Smell, we're not going to get into detail, but that could be another comfort complaint that's not on our list that we're talking about. Another thing to note about returns is it's not necessarily the size of that gigantic metal grill blocking that, the net-free area of that grill. What really matters is the path from that grill back to the equipment. Size of the smallest size of that path back is the size that dominates that return's performance, not necessarily the grill size. It can also be noted that there's construction debris left in behind the grill that could introduce a 5th or 6th comfort complaint that we're on now of dirt getting in the house.
Oh, before you move forward, just so you guys know on the phone, so that when you're looking at these slides later, you can discern whether an image is a positive thing to do or a negative thing to do. If it has a pretty pretty distinctive thumbs down. This is a photo that you are not supposed to be doing. So if you have a practice that looks like this, it's not a good thing. But if it's a thumbs up, it is a good thing. I know a lot of times photos will be really helpful for you to remember later. And that's just our way of kind of labeling for you so you know which is a good practice and a bad practice. Sorry, go ahead.
So characteristics of a good return design, it can't be stated enough that system performance can be greatly affected by the return. We tend to think about supply and getting the air to the room, and return gets neglected. The return size it's sized by the total CFM going back from that space, first floor, second floor, wherever that return is located. Ideally, there's one on the first floor and the second floor and the basement. Every closed off space has some return path. That can make it a fairly large duct. It's the first duct that we look at when we do HVAC design or train on HVAC design. We say look at the return first. It's the biggest duct. It needs some space on that floor plan. It needs a chase to run through. It needs a way back to the equipment. And it's going to influence where the equipment is located, or the location of the equipment is going to influence where that return is located. So sort of tongue-in-cheek, what we say is you wouldn't design a kitchen without a space for a refrigerator. Why would you design your whole house without space for your HVAC system, in this case, the return? It's an early consideration. Another prevention item that's fairly low tech but is actually effective is a simple ceiling fan, especially in those two-story large volume spaces. Ceiling fans can be thought of, oh, that's so 80s, a little bit outdated, but they can be an effective way to get mixing in those large spaces, both in the heating and the cooling system. They can be run to force air down or to force air up. I have seen builders who will spec into those great room spaces the ceiling fan box because it requires an extra, a different type of box to handle the weight, and the switch. They just spec it in whether the buyer purchases it or not. If the buyer selects it, yahoo, go ahead and charge them for it. If they don't select it, it gets drywalled over, but you have the assurance that it's there. Should an issue arise later, it's a lot easier to add a ceiling fan to the space. So a little low-tech, inexpensive solution. Moving on to issue number 2, high humidity in the house. If I didn't say it early on, I'll say it again now. All of these issues are real things that we've seen in real houses in various parts of the country. Different parts of the country tend to have their own unique issues. We associate high humidity with the Great Lakes region and the Southeast year-round, not so much in Montana where I live or Arizona, but these all come from real-life experiences. High humidity can be caused by that part of the country you live in, and simply the outdoor environment is impacting the house, or our indoor activities in the house. And it can manifest itself in very different ways. Hot and muggy is what we expect from high humidity. It can also lead to a cold, clammy comfort complaint, or heaven forbid, the condensations on surfaces that lead to a building durability dreaded M word in the houses that we don't want to have to deal with. Predominantly primary large cause of high humidity in the house, regardless of what part of the climate it's in, is oversized equipment. I know Brad Obert has talked about oversized equipment. He talked about it for years and years and years. I took over the message on this 5-6 years ago in my Invicus career. We've really tried to hammer this home with every builder, trade contractor that we touch. We've spoken with builders all over the country, and by association have spoken directly with trade contractors all around the country. The oversized phenomenon is really, really hard to overcome. We see it almost initially with every interaction we have. So it's not crazy building scientists saying you need to size your equipment right. It's ACCA, the Air Conditioning Contractors of America. It's their own trade group that came out with these manuals and these protocols for sizing equipment. It's a very back and forth process. It's all driven by the load on the house. And that load is a design day scenario by intention to cover the broadest spectrum of time, not the worst case scenario that tends to be where sizing occurs. Oh, it was 105 and 95% humidity here yesterday. So yeah, there's lots of information that we're going to provide you at the end for resources.
Yeah, if I could just jump in for a second. I mean, what's going on here? The reason that oversized equipment doesn't remove humidity is that this equipment, matches the thermostat temperature set point very quickly. It might kick on when it's, say, 85 degrees outside and meet that thermostat in 5 minutes. We see this all the time, and then it kicks off. Well, what's happening is that coil inside that system isn't able to fully extract the humidity from the air. That coil is getting wet, and it doesn't have an opportunity to shed that water and thoroughly extract humidity. And so that's why you really need the system to run longer so that that coil can drip and adequately remove humidity.
And that's where the cold, clammy sensation or complaint comes from. Thanks, Andrew. Another cause of high humidity in the house that we maybe are overlooking, we're building a well-built house with intentional air sealing, attempting to keep the conditioned air inside the house and only bring in our intentional ventilation air. Accelerated construction schedules, building those houses quickly has led to issues of condensation and mold inside houses. It's a painful financial thing, but we need to either allow time in our schedule or provide additional dehumidification. I have seen dehumidification, temporary dehumidification in houses where you would not expect it. I've seen it in Colorado where it's generally dry, but because the house is tight, the moisture that's introduced with construction, they have chosen to add that supplemental dehumidification. And then I've seen it in Minnesota as well, where yes, you have hot, sweaty summers, but also due to climate, they have to pour basement slabs in the wintertime, adding moisture. So the image is a very, very wet slab-on-grade foundation. And you can imagine if we frame on that when it's firm enough to walk on, but we haven't got rid of that moisture, that could be a problem.
We do have a question that was typed in. It was on one of the previous issues that you covered. But please, we are going to hold that until we do the Q&A, the first Q&A break. But just a reminder to people who might be thinking of something, type in your questions and send them to us, whether it's about the research that we're doing, whether it's about comfort complaints with HVAC as we get through this section, or whatever it is related to this topic, and we'll try and address those in probably the next 10 minutes or so. Back to you.
Thanks, Betsy. So one possible solution for those varying loads in the house is variable equipment, multi-speed, multi-phase, multi-stage equipment. This can be a solution. We have seen where it can also cause an issue. There's a few considerations you need to do. There is no silver bullet in any of the stuff we talk about. It's all the standard building science responses. It depends. Every question you ask, it depends. The variable speed equipment is addressing the load, but not necessarily the distribution. We're not at the point where we have variable ducts yet. We saw that University of California, San Diego is developing smart clothing that will vary based on the room temperature. When we get there, maybe all the stuff goes out the window. The big one I want to pull out here was the occupant expectations. When you have sold something to the home buyer for more money, you've made a association in their mind that they're going to have better results from it. It's very important that the design acknowledges that and addresses it, and you're not just adding cost hoping that everything will be better. Cause for high humidity is our indoor activities, cooking, showering, bathing. Our outdoor ventilation that is required and we want to have in there, if not properly handled, can also add high humidity to the house. It's important to consider that in your ventilation discussion. Spot ventilation for those showers and cooking activities is critical, as well as whole house ventilation. I should have teed this slide up by saying ventilation is a very hot topic, a very controversial issue. How much is enough? How much is too much? How much is not enough? In mixed and hot, humid climates, we really promote a controlled, balanced ventilation strategy. In dry and cold climates, we still are seeing good strategies that are exhaust only. The caution with exhaust only ventilation strategies is don't forget all that effort that you put into air sealing the house. Your makeup air for that exhaust is intended to come through the cracks and crevices that you're working really hard to seal. You could have a push-pull effect there. Bottom line is it must be included in your HVAC scope and design. Too often we still see the V in HVAC ignored. Third issue we're getting to is the hot and cold rooms. We talked about stratification that can lead to this, but now we're going to talk about more direct causes of it. Air must be delivered to the room at the right temperature and in the right proportion, so you don't get a draft or overheating or overcooling. And again, this could be an envelope issue, and we can come back to that, how you distinguish between the two. But right now we're going to talk about how the air is delivered to the room as a cause and a place for a solution. Long duct runs through unconditioned space can and will lose energy. Even through an insulated duct, you can still lose your heating or cooling energy through that. Duct tightness, duct blaster tests are becoming part of code, are part of energy programs. That's good. Make sure the right amount of air is getting to where you intended it. The notion of having to bring that air all the way to that outside wall or window and wash that outside wall or window is becoming an antiquated notion. We have put effort into better windows, better insulation, better air sealing. We don't necessarily need to wash that wall with conditioned air to change the temperature at that point as much anymore. We can use strategies like throw registers, ceiling or wall throwing registers, take that air, deliver it to the room in a manner that it mixes with the rest of the air in the room, and you get the comfort condition you want, and eliminate this really long duct run. Ducts inside conditioned space, that is the mantra, that is the holy grail we all want. There are challenges with that. Builders may not want to see soffits and drop ceilings in their spaces. It kind of disrupts the architecture of the house. Short, compact ducts with good throwing registers is a good first step, even if that duct is still outside the conditioned space. The whole goal of bringing ducts inside conditioned space is to reduce that energy loss or gain, the load on that duct. The shorter that duct is, the less surface area there is, the less gain or loss on that duct. Another cause for hot and cold rooms is overpressurizing rooms. If the air does not have a good return path back out of the room, you can pressurize the room and actually force the conditioned air to other parts of the house. The standard customer relations complaint here is, I put my baby down for a nap, I go get her back up again, and she's all hot and sweaty. That's because mom or dad or caretaker has put the baby down for a nap, closed the door to the bedroom, and there's not a good return path for air to get out of there. Conditioned air stops getting to the room, and baby gets hot and sweaty. The door undercuts have been shown to not work. They really don't work. You can see how they don't work in houses where you see the dirt or dust line at the carpet line between the door and the carpet. That's air trying to get out and the carpet being a filter for it. Our recommendations are the over-door transfer, the jump duct through the ceiling, or in cases where privacy or noise constraints won't allow either of those, the dedicated return back to the equipment from the room. Dedicated returns from every room are okay. They can be problematic if all that resistance and restriction is not considered in the design. Another potential prevention is providing zoning. It comes with similar cautions as the multi-speed, multi-phase equipment does, that it's not the silver bullet that you can just throw zoning at a house and solve the problem. Zones need to be appropriately laid out. Strongly recommend mechanically controlled zoning and not the weighted balance damper, and this just comes from what we've seen in the field. Those weighted balance dampers are very hard to set up and get them to work properly. Mechanically controlled, electronically controlled, truly controlled dampers will integrate with your equipment and only open that zone when you want it open and close it when you don't want it open. There are significant implications in the duct design. You have to accommodate that excess air if a zone is closed. And again, the occupant expectations, when you've sold them something, make sure it's designed to perform so you haven't set them up for a disappointment. On appropriate zoning, Andrew, you have some thoughts.
Yeah, I think this is a good time to bring up the importance of considering the geometry and design in the house. Now we're focusing mostly on the mechanical system in this webinar. Obviously, the geometry and design of the house has a big impact, and especially with zoning is where it's often most important. It's not always that you might have a two-zone system with a two-story house. It might not always, you might not have the second zone on the second story and the first zone on the first story. You really have to think about things like solar heat gain and orientation. And if you have a sunroom or something, that might be your second zone, and the rest of the house is on a single zone. So with zoning, it's very specific to the design of the house and things like orientation. So if you have the same design in a couple different situations, you might actually have to reconsider your zoning approach. So I just want to keep bringing up the concept that you have to really think about the design and the impact that that might have on your HVAC system.
Quick side note, red and blue hockey players on there. I think we were anticipating a Game 7 tonight. That's not going to happen. Kudos to Chicago fans and condolences to Tampa Bay. The fourth issue we're going to get into is noise in the house, noise associated with the system, not necessarily the wife snoring. Equipment drone, it is the wife snoring. Equipment drone can be a very annoying problem, and the air whistling, air movement noise. As the house gets tighter, more air sealed, better envelope, those noises become much more prominent in the house. All the outside ambient noise is gone, and you can really focus in on that. And it can be quite annoying. Equipment-related noise, specification and placement. As you're selecting where that return duct is going to go, what chases it's going to have, having the equipment directly connected to that blower can be a big source of noise. The drone noise. Generally, better equipment, higher efficiency equipment, has better componentry. The 80% B-vented, low first cost equipment is low first cost for a reason. the non-variable speed motor. They're generally just noisier. So there's more benefits than just energy efficiency to stepping up your equipment specification. And then decoupling that motor from the room where the return grill is with a couple simple turns really can reduce that equipment noise. Register and damper related noise. High velocities at the register will cause noise. The louvers in the register are not intended to be a balancing device. Every duct run should have a balancing damper in it. There are a couple quick things you can do in walking your houses to see what attention to detail is being put to it. If you walk your house and every single room has the exact same size register, whether it's a little powder bath, a laundry room, or the master bedroom or living room, probably not a good attention to detail in the design. Those rooms are going to require different amounts of air, so they are going to have different size registers. If you walk your house in the rough mechanical stage when the equipment is in but the wallboard's not up yet, and you don't see some sort of balancing damper in the system, there's no way to balance that after the fact. If one room's getting too much air, one room's not getting enough air, you're stuck with what you have, or you're making a significant change. So dampers are important. Damper placement can be challenging, especially when you bring ducts inside conditioned space. You don't have access to it. The photograph shows a balance damper right at the boot. This is one solution to putting a damper in an inaccessible location. We would rather see that damper an arm's length up inside the duct, so at least it's not at the boot. That's why this picture gets the thumbs down. This is a picture of the damper a little bit farther back. This happens to be a basement, so the lever is accessible to be able to adjust it, but you can imagine reaching your arm up inside that duct and moving the balancing damper. This can really impact noise at the damper.
At the register. Yeah, and something else to consider is just the design of the grill itself can also impact noise. Just like we saw before, that the design of the grill can impact throw. Some of the more simple grill designs might tend to be louder. You're basically creating a whistle, and some of those rough edges on the register grill can significantly increase the noise that's being generated.
So are you okay on time, Betsy?
Yeah, we are okay on time. We're in really good shape.
We're wrapping up the issues section where we talked about you know, the 4 types, and actually expanded that into 6 types of comfort complaints. And we're going to move on ahead. One last thing. So all of those solutions were design-based, proactive things you can do. There's one more component to design, giant air quotes around design, and that's the commissioning process. Commissioning your system, going back in through the process and at the end, and making sure all of the components are performing as designed can be a real risk preventative way to ensure comfort in your house. This way, when you get to the end and you do get a comfort complaint, you have something to reference back to. It was working at this point. Perhaps it's an envelope issue, or perhaps something has been changed by the occupants of the house. It's a conversation piece between the builder and the trade. It's not a cops and robbers game. And we're seeing some of these components become part of code and energy programs.
Okay, we do have a question. This goes back to the issue of system sizing that you mentioned earlier, and the question says, the HVAC contractor gets the complaint call when the temperature extremes occur. So this provides incentive to oversize. How do you convince HVAC contractors to follow ACA?
I've had a little bit of success with this. I've spoken with several contractors in several different parts of the country, and some have actually seen the light and bought into it. That one statement about this is the air conditioning contractors of America seems to get some purchase with them, so it's not just crazy scientists telling them what to do. The fact that it's actually code required now should have a pretty good impact on it, whether they're actually doing it or not. As the builder, your gut check on this is to ask for the manual J report, ask for the manual D duct design, and see if they can produce something for you. We've seen everything from cocktail napkin sketches for duct design to a sales and marketing PDF of the floor plan with some ducts drawn on it, but it actually ran through staircases in places where ducts couldn't actually run. It is a very tough conversation to have. Bless their heart, it's a very, I would say, stubborn trade to deal with. I get a lot of response I get is, this is the way we've done it for 30 years. But my answer to that is, it's not the same house you were building 30 years ago. Is that everything?
Yep, that's one so far.
So what to do when things go wrong in troubleshooting? People, the human condition, people do things, people have expectations. The unreasonable setback schedule. In the active adult communities, it seems that people will leave their houses for long periods of time, come back, try and set their thermostat to 70 degrees, and expect it to be 70 degrees within minutes or maybe even hours if they're being reasonable. That's not a reasonable expectation. We get this expectation because we jump in our car and we crank on the AC, and we're pretty much cold quickly. A house is a lot more volume. The server room scenario where they're trying to keep one part of the house cold during the winter heating season without supplemental equipment, that's pretty hard for any equipment to do. And then the big party. I have 25 people at my house. I have my air conditioner running full blast, but I also have every window and door in the house open. Why isn't my house cool? A silly or unreasonable expectation. We can set silly expectations, zoning for zoning's sake. Again, once you sell them something for more money, you've put an expectation in their mind that it's going to be better. It needs to be designed to be better. Bigger is better. In my purchasing days, I've actually dealt with a customer complaint that my neighbor over there got 5 tons of air conditioning. I only got 3 tons of air conditioning for the exact same house. It was a tough conversation to have that, well, your 3 tons is actually right and better for you than his 5 tons is. And then the Mercedes effect, that if we just buy better stuff, throw more money at it, we're going to get a better house. Again, lots of design considerations to make sure we don't set the wrong expectation. When you get that problem, you need to go in and delayer that problem. Somebody does. So it's not you, it's your trade contractor, it's your field guys and gals. Somebody has to do it. The first place that Ibicus starts when we go to look at a house is we just go observe and see what's going on. Are they doing something crazy with the controls in the house? Is there something, you know, is there a big crop of something growing in the basement that's causing the humidity problem? The observation can really eliminate a lot of the complaint up front and address it quickly. You're going to get the installing contractor out there to test their system. Everything tests out okay. You're going to have to step back and evaluate the design before you take action. But the farther back in the process you go, when you get to the design issues, it can be a lot more money and a lot more time for you, the builder. Those silly things they do, have they changed the filter? I have been on complaints that my HVAC system is not running and gone and opened up the filter compartment and there's just a big dusty mess in there. I don't know, we tend to think of this more as the first-time home buyer. They've been in a rental house, but I think it happens everywhere, even with Ibicus employees. In the extreme, you may have to have a small monitoring system installed. The more sophisticated contractors that we deal with, I mean, some of them have actually gone and purchased their own little standalone monitoring systems so that you can get a quantitative answer to that subjective evaluation that defines comfort so that you can have a more reasonable conversation with them.
Yeah, and some of these issues are time varying as well. So you might show up at the house and it's fine today, but tomorrow or the day before might have been when the problem was. It's kind of like, your car, it might have a funny squeak or something. You take it to the mechanic and you can't get it to reproduce the problem. So one of the ways to identify the problem is through these lightweight, cheap monitoring solutions here that can really identify the specific cause to your problem.
Yeah, if you were at the Tech Summit a couple weeks ago here in Pittsburgh, you heard a little bit of discussion about the potential for the OBD plug-in in a house. You take your car to the mechanic, they can plug in and tell what you've done with it. Again, that's not here yet, and until it gets here, this can be a way to get that information for a complaint. When they show up to test it, who is showing up to do the work? Who's showing up to address your homeowner's complaint? Is it the best, most qualified person because you want them in that house one time, fix the complaint and not hear about it? Or is it the new kid on the block who gets stuck with warranty work because that's not where they're making money, so they want the lowest cost at it? This is a conversation for builders to have with their installing trades. Probably way too much detail for everybody on the phone, but just to make you aware of what they should be checking and in what order they should check it in. Observing that basic maintenance issue, looking at the pressures within the ducts. Is the equipment set up properly, fan speed? Are the airflows in the rooms as they should be? Is the temperature of the air entering the room what it should be? And then going to check the refrigerant charge. Charges last on there for a reason because we have experienced where that's the first thing they want to do is jump out of the truck and check the refrigerant charge. All those items above that affect what the charge level is. So charge may not be the first thing they should be checking.
Before you move on, go back to that for a second, we have a quick question. So this is a pretty detailed list if it's an HVAC problem, but what if it's an enclosure problem?
You have to delayer the problem at some point or another. So if you have taken the step of having commissioning on your houses, you have some documentation that that equipment was commissioned properly and working properly, maybe then you focus on the envelope first. Tools for looking at the envelope, an IR camera, a blower door test to look for leakage. You can kind of get it if it's a hot room, cold room complaint and it's a room over the garage and the air being delivered to there is the right volume and the right temperature, I would step to looking at that insulation level in the garage. There are a few known problem areas in the house with thermal enclosure that may lead you to thermal enclosure first and not HVAC. But most likely the HVAC contractor is going to be the one that gets the call if it's a comfort complaint, whether it's an envelope issue or an HVAC issue.
Okay, cool.
Evaluating the design can be very, very costly. Again, some of the things you can do to evaluate the design on your own is simply ask for the documentation. The manual J, that's the load calculation part, that needs to be done per the specs that you're actually building the house. So get that report, look at it, make sure they have given proper credit for everything you're doing in the house or haven't overestimated what you're doing in the house. The duct layout, like I mentioned, make sure it actually matches what goes installed in the house. It can result in, sorry about that, it can result in significant structural rework if you have to add a return to a second floor where you didn't have one there initially. Moving or resizing registers, if you have oversized registers or oversized duct, think about that. You're either tearing up flooring and trying to match a smaller hole, or anybody who spent time in the field with ceiling repairs, you don't want to move a ceiling register and have to do a ceiling repair. They stick out like a sore thumb, even with the best repair jobs. Equipment replacing can be quite costly and will impact the duct size, leading to further destructive repairs. So even in a well-built house, comfort complaints have happened. We have been out there to Energy Star houses. We've been out there to what we consider well-built houses by builders who really pay attention to the details and they have comfort complaints. You may or may not be aware of this. The sticker on the side of the equipment may be the first thing that homeowner sees, and maybe calling your contractor before they contact you. If that problem is not dealt with, that can really cascade down to where you don't hear about it until it's a big issue. Therefore, it can have a big impact on your business. And awareness and prevention early on in design and the commissioning process can really help eliminate this. Moving forward, equal emphasis on design and commissioning, making sure you're getting the design you need and it's installed the way it should be. Committing to it, it doesn't take very many kicks in the shin from complaints before you want to address it. Getting your trade to engage, as evidenced by the one question we got, can be challenging, but it's an ongoing dialogue between the builder and the trade to get to this point.
One last question that we have is also enclosure related. But if you've got that checklist, the commissioning list for HVAC, and you mentioned blower door tests to do it on the back end, is there a good commissioning list for enclosures or things people should be checking for in the construction process to look for proactively what issues might result in comfort as well on the enclosure end?
Inspect what you expect is one way. You know what your specifications and your scopes are. Your field guys should be looking to make sure those items are installed in a quality manner, not just the pieces there. If you're participating in Energy Star, you are forced into doing the thermal bypass checklist. That can be a resource to you even if you're not participating in the program. It's out there, it's published information. But mainly your guys need to make sure things are being installed the way they should be installed.
Mm-hmm. I'm going to field this one, Kate, just because I think we're actually moving into the final, and for some reason I can't advance on it doesn't like my computer today. We just got a question, will the presentation be available as a handout for attendees? Absolutely. All of the presentations that we've done and some of the resources that you see on your screen right now that say strategy guidelines or measure guidelines, in particular, one that's jumping out at me, HVAC equipment sizing. We did a 3-part webinar series with Arlan as well, I believe, that connected directly back to these guides that we had created through the Building America program. So both today's session in PDF format of the slides, as well as an archive of the webinar, in case you have others on your team or your trade contractors who need some backup to say why right sizing is important, you can make this free resource available to them. We'll send you the follow-up link to where the archive is posted, as well as the PDF of the slides. And the list of resources here are also going to be made available to you. Just so you're aware, we are actually launching a new version of our website within the next 3 weeks. And given the timing, what we're going to do is put a link to all of this good stuff for you on the home page, so that when we launch that new site, you don't lose access to any of these resources. You'll still be able to go to the home page, which isn't going to change. The URL will be the same. It's on the bottom right of this slide. And click on that link and find any of the resources that we have available related to this session or any of the other events or webinars that we've done. But again, thanks to Arlan and to Andrew for sharing your expertise. Thanks to the Building America program for giving us a venue to do some of this research and pull together these resources as well. And if you have any specific questions that you wanted to address, maybe they're more of a sensitive nature, maybe you want to talk more directly about some of the research that we're doing, you can contact either Arlan or Andrew on that front. If you're not a member currently or a sponsor or a friend of the Alliance, if you will, And oops, I will fix that when I post it. My phone number is correct, but I'm not Andrew Poerschke. I missed that when I added that, so my apologies. You will be able to email me directly as well, or give me a call if you have any questions from an alliance front. And just one more little plug. When you go to our website, we just finished our tech summit a few weeks ago. We had a lot of information we started to share on connectivity there. We did not touch on it today, but I really think that there are some cool opportunities coming out with controls in HVAC that will take some of the crazy factor out of, when to use ventilation and what humidity you might be seeing in rooms. There are some cool little humidity sensors that Panasonic has brought out now that might be interesting for you guys to look at, and some other opportunities that would help you mitigate some risk by having access to more information or bypassing bad practices on behalf of your homeowners by offering them those opportunities. So there's some information on that from the Tech Summit, and then our annual meeting will be in Austin, Texas. October 13th is just kind of a friendly get-together for people who arrive early. The meeting itself is the 14th and 15th, and registration is now open to alliance builders and sponsors. If you're not a member currently, or if you don't technically fit into the category of a builder, and you'd like to participate, you can also reach out to me and request to be invited. We are a friendly group, but we try and get the right mix of people in the room, and we'll extend an invitation to you if we think it would be both of value to you and of value to our builders for you to participate. So we welcome contact on that front as well. And again, thanks everyone for participating today, and have a good rest of your afternoon, and look for some follow-up from us in the next few days.